All right, the most common question that I get asked when we're working with new equations is, how do I find that? If you have an equation and you need to solve for a particular variable, but how do I do that? How do I find that? I'm going to walk you through the steps of rearranging your momentum equations, but this is something that you're going to have to learn how to do on your own, so that's why I'm taking you through step by step. So let's look at our elastic collision equation, and you can see our equation right here. This is the full equation. M1v1 plus M2v2 is equal to M1v1 after the collision plus M2v2 after. Now let's solve this for v1. Okay, let's say I want to know how fast is the first object moving before the collision. The very first thing that you're going to have to do, you want to get the M1v1 all by itself on one side of the equation. And the way that you do that, you have to get rid of this M2v2. So you're going to subtract it. You're going to subtract it from the left side, and whatever you do there, you have to do on the other side. So you're going to subtract it from the other side as well. Well, that cancels out, so you're left on the left side of your equation just with your M1v1, and that's equal to all of this stuff over here on the right. Well, now you want that mass to go away, and so because it's multiplied by the v1, you can divide now. So we take each side and divide it by mass 1, as you can see here. Then on the left side of your equation, that cancels out your two masses and leaves you with this is your final equation right here, solving for v1 before the collision. How about if you want to solve for v2? We're going to start with the exact same equation to begin with. But now I want to solve it for v2. What's the velocity of the second object before the collision? We're going to do it exactly the same way. First thing you have to do is to get rid of this m1v1. The way to do that is to subtract it from both sides. You can see I'm subtracting it here and here. That cancels out on the left and leaves you just with your m2v2 on the left is equal to all of this over here. Then you want to get rid of the m2. You can divide by that. Divide both sides by m2. They cancel out on the left, and this is your final equation when solving for v2 before the collision. How about solving for our velocity after? Again, we're going to do it exactly the same way. So I'm solving for v1 after, which means that I want to move this first. I need to get rid of that so that my m1v1 is all by itself on the right side of my equation. I do that by subtracting, just like I did before. Subtract over here, and I subtracted it over here. That cancels out here on the right, and it leaves us just with m1v1 after is equal to all of this kind of stuff here. Then we want to isolate the v1 after, so we divide by the mass, divide both sides by the mass, as you see right here. Cancels out on the right, and here's your final equation. We'll do pretty much the exact same thing when solving for v2 after the collision. So we want to isolate this v2 after. We're going to do that by getting rid of m1v1 after first. You do it the exact same way by subtracting from one side and subtracting from the other. You can see that it cancels out on the right, and we're left with all of this over here on the left side. Now you want to get rid of this m2. You want it to go away, so we divide both sides by m2. Cancels out on the right, and here is your final equation, solving for v2 after the collision. Now let's look at a different type of collision. Now we're looking at inelastic. These are the ones that stick together once they move. This one's a little bit easier to move around. So let's solve for V1. I want to know how fast is the first object going before they collide. So the first thing I have to do, again, same as before, is to subtract your m2 v2. I need it to go to the other side of the equation. So I subtracted it here, I subtracted it here. You can see that it cancels here on the left, and I'm left just with m1 v1 is equal to all of this over here. Now I want to get the mass away, so I can divide both sides by mass 1. You can see that they cancel out here on the left, and here is your final equation. If I wanted to solve for V2, I'm going to do that almost exactly the same way. The m1 v1 needs to go to the other side of the equal sign. So I'm going to subtract it from both sides. Subtract it here, subtract it here. It cancels out on the left and leaves me just with m2 v2. Everything's still on the right. Then I want to get rid of my mass, so I divide by mass 2. That cancels out as well, you can see here. And I'm left with this equation. In an inelastic collision, solving for v after, the final velocity of both objects moving together, that's even easier. So I want to isolate this velocity after. So all I have to do is just divide both sides by m1 plus m2. I divide by the combined mass, because you add those two masses together times the velocity. So I divide right here, and I divide both sides by the same thing, and you can see that that cancels out on the right, and I'm left with here is the final equation to find final velocity for an inelastic collision. Our last type of collision is a recoil. Now remember, recoil is what you get when you have something like, say, a gun firing a bullet, a cannon firing a cannonball. We've done it in the lab with the two carts that are starting right next to each other and then pushing off. So we're really just looking at the after velocities for a recoil. And in this case, the m1 v1 after should be equal to m2 v2 after. So the momentum of the first object should be equal to the momentum of the second object. Let's say that I want to know how fast is the first object going after the recoil. It's really, really easy. All I have to do is just divide both sides by m1. That cancels out my m1, and I'm left with this equation here. If I want to solve for v2, I want to know how fast is the second object moving after the recoil. I do it exactly the same way. So I want to isolate this one. I'm going to divide both sides by m2. They cancel out, you can see here on the right, and I'm left with this equation. That's it. Good luck on your homework. Make sure you come and ask for help if you need help.